Hey YouTubers, we're going to start today with a 6-meter antenna, homemade. Got the Nano VNA running, checking it out. It's looking pretty good. This one here is for 6-meter horizontal for sideband, and it covers, I've checked it with the LNA or the VNA, and it's under 2 across the whole band of 6-meter. I'll show you how I built it, what it's constructed of. You can see it's got some PEX pipe here along the wire built inside. That is actually 6-gauge ground wire. I'm going to replace this hardware with bolts, but I got to strengthen this bottom plate up. It's a little bit too wobbly, but I have radial arms for it. These are the radial arms. It keeps the 6-gauge wire straight. You can see it's a little bigger than that, but it fits actually really rather well inside the PEX pipe here. Show you that. Took me a while to get it tuned, trimming it off just right. Oh, you see my stand here. I didn't have a coupler, and I didn't want to trust it. I had one break. If you watch my previous videos, you can subscribe, and you can see my breakage I had of a pipe. But what I figured out, I saw a YouTube video. Dude took a torch and heated up the pipe, and it got really flexible, and I just kind of wormed the pipe around it and got it bigger and just kept heating it as I went down. You can see where I got it too hot. Wouldn't do that, but I'm going to just cut it here when I'm done and put a regular coupler on it. This is my test little stand that I got. That's filled with concrete. That was $2 and something. That is a old LCD screen backing. Just kept, kind of makes a nice platform. And then I stuck the actual, this is an 1.25 EMT thin wall. It was expensive. That was $33 for a 10-foot strip. And then you can see I just heated it and worked it in there. Just kind of got to work it around. And that's just what I test off of. And I also mount my camera on it. I can't show you the VNA screen. I don't want the camera to be all shaky and stuff like that. I'd rather get it set up so you can see, and I'll show you some stuff on the VNA, so you can, if you got one of them little ones, the Nano, like that, you can download the software from Nano VNA. I typed it in Google, and it took me to this really oddball web page. It just had like script on it, and but it lets you click on a few things, and you can download the software, and that'll let you run the software for the Nano VNA there. You can see I've got the antenna. I've got the band or the range set for the full sweep to 900, so it's really showing a lot. But I'll try to include some. I'm working on my video editing, so I'm going to show you what it does outside. It's even better outside when I got it away from all this metal stuff and everything in the room. But you can see how it's put together. I'll show you. You should be able to, the way I built it, I should be able to run about 1200 watts through it, sideband, being horizontal. I guess I could turn it vertical. It's really a dipole is all it is, but I'm going to insert a 1-to-1 balun. They call them chokes, common mode chokes, but it's really a balun. It takes, this is a balanced antenna. A dipole is a balanced antenna, and I'm taking it to coax, which is unbalanced. And that 1-to-1 balun will mount right here underneath, and I'll bring the wires up to each end. I'm just testing this right now, getting the length kind of set in. But yeah, the balun will mount here. Now it's a 2,000 watt balun. So I'm building this as a transmit because I'm gonna take my test, because I'm not a ham yet. I learned most of my stuff in CB World, and just never took my ham. I had other things happen, and never took my ham license. So I'm gonna go get my ham license and make that into some YouTube videos, and that'd be all right. That'd be cool. But yeah, I'm gonna show you this. It's taken apart right now, but the connection here, this 6-gauge wire, just regular ground wire, I used. Handle up to 600 volts. Once you hit over about 600, this outside gauge, or this outside shielding, starts to deteriorate. So I needed a support. And you might ask, why didn't I make it out of aluminum tube, like tent poles or something? And the reason why is you got to insulate the hell out of it right here. And you can have flashover if you run high power through it. Now, this is a little heavier than a tent pole style antenna, but you might think because I used thicker wire, I'm getting more power. No, that's not why I used this thick wire, and I'll show you over here. I made this antenna using this house wire, 14 gauge, and it worked good. It was tuned in great, but there was a problem. And I'll show you over here. On the VNA, on the scale, it was super thin. It did not cover but maybe 50 to 51 on the 6-meter scale. And the thinner your wire, kind of applies the same built-in magnetic loops and stuff. The thicker your material is, the wider your bandwidth will be. So I jumped up from this 12-gauge wire, this household wire, to this 6-gauge wire, and that covered the whole 6-meter band right there. So just by changing that thickness, this was solid, but this is stranded, of course. But really what matters is your thickness. So I could have made it out of tent pole material, something like that. But the problem is you got to insulate this with plastic or something to insulate the poles where they connect, and you got to almost have a connection that goes through. So you need to have a plastic kind of mount, and I don't have a 3D printer, and I bought this for $7 at Lowe's. So I got this connector grommet out of an something else old. I had it laying around, and then this is just a short piece of coax I cut the end off of, added a barrel connector there, and it stays with this. So the barrel connector just stays there with that, and this runs through, and this wire is already insulated. It'll handle up to 600 volts, so it should run 1200 watts, no problem, without any flashover. And it's insulated all the way out through the PEX pipe. The PEX pipe runs completely through, and then it couples right here with a piece of pipe. I used really thick wall pipe. Don't use that thin wall stuff. Use a thick wall pipe, and I bolted it underneath one side. You can see in there the bolts with the nuts running through there, and then of course I'll try to get a better view of it for you here where the pipe is. You can see the piece of pipe inside there. It's split. I split it in half so it could have two pieces, and it gives me a stop point for the PEX pipe when it comes through. Right there. Right in there. So they kind of butt up against each other, and this wire doesn't even see this metal. It's actually on the end of it there. I came back about that far, drilled a hole, and then I split the pipe down the middle, and I bent the 6-gauge wire, and I just split it through the crack, and then landed it in the hole. So it's got a nice solid mount. Now you don't want to leave this PEX pipe out in the sun. It says right on there, avoid direct sunlight. So it's really just a support, because that number 6-gauge wire is so thick, and they roll it on a roll, and it wants to go back to that original roll form. And if you have any droop, and I'll pull this back, if you have any droop in your ends, it screws up your standing wave bad. It messes with the tuning of the antenna. So you don't want that droop in your, and the guys making these dipoles on 80 and 40 meter and stuff, and if they got any droop in their wire and they're wondering why their bandwidth is so small, it's because they don't have a super straight wire. You need that wire to be, especially if you're making an inverted V, you need that wire to not have any slack in it at all. But what I do is these have an end on it, and I cut them the other day. There's all the cuttings off of it to get the length down when I tuned it, and they just slide on right here, and it keeps it level, keeps it flat. Now I will tell you, on this design, these are a weak link right here. They're not butted up against the pipe, so you're really literally, the depth of that thread is the thickness that you got for strength, and it sucks. So I'm gonna change this. I was just building this to test it, but this will have a different connector on it. They make one adapter that slides on, and it automatically comes down to the 3/4 inch. This is 1.25 pipe, 1.25 coupler, and an inch 1.25 to 3/4 C PVC, and I bought that because it's cheaper. So I'm going to paint the antenna anyway, so it's not going to matter. But I live in an apartment, in case you guys didn't realize. I live in an apartment, and most people that live in an HOA or an apartment have a lot of trouble with radio stuff, and I was able to get permission to put an antenna, and if you watch my other videos, I got a compact antenna tri-bander for 2 meter, 220 and 440, and since it's so small, and you just need to get to a repeater, and I can get to 6 repeaters with 5 watts off that little radio there. That's just 5 watts, and I can get to 6 different repeaters where I live with that antenna up on the roof, and I'll edit in a picture. I'm learning how to edit in now of my antenna, compact antenna with the base mount for you, so you can see it, and I'll edit it in there. All right, and then pretty much that's how I did it. I just cut the ends little by little. And what I found out by making it, if you look at my PVC pipe here, they don't quite match. There is a 1/2 inch or 3/4 of an inch. I lost a 1/4 of an inch here. One of these is shorter than the other, so there is a 1/4 of an inch. And then, so it's about a 1/2 inch. And I figured out where it was at. It is when I trimmed this side of the shield side. This is the hot side coming off the coax. This is the shield side. When I trimmed it, it ended up being a 1/2 inch shorter. But to be honest, it didn't really matter. It didn't really change the standing wave at all. If anything, it kind of helped it. So it goes to show you don't have to be so perfect, or you can kind of make a mistake and learn from that, or sometimes your mistake of cutting it too short works. So just so happened mine just being a half an inch, about a half an inch difference, and it really looks good on the VNA. So but I'm going to reinforce this underneath, give it a little more strength, put a little plate, bolted plate to it, and then I'll wrap these and this in weatherproof flexi tape. I got it when I purchased my base mount antenna. So you just cut it off into little strips and then wrap it around. It's stretchy, it's really nice. It's pure rubber, I think. So it'll help protect from flashover off this hot side, if any. You can see how close it is. There, I can get my finger there underneath of it. So just to help protect that connection there, that should work. But that's the 6-meter antenna. Now what I'll do is I'll edit the video here, and we'll jump over to the VNA, and I'm going to have to edit a video there so I can get it outside for you, and you can really see the bandwidth on it and how low the SWR is. I got it down to a 1.0 on a 51. I wanted to move it a little further over so I could cover the whole band. But it's awesome, and I haven't transmitted on it yet. I can't because I'm not a ham yet, but I'm, like I said, I'm working on getting my license. The reason why I haven't become a ham is I had a traumatic brain injury, and it kind of messed me up. I lost some things, how to do things, and one of them was kind of comprehension and reading. I can watch something and learn it real quick now, but it's weird. But yeah, I'm gonna probably get that situated there, get that finished up, so you can see you can see how wobbly it kind of flexes there when I put pressure on it. I don't think that it'll hold up very good in the wind. Of course, it won't have the dangling. It'll be all nice and straight, solid. But I'm still going to fix that, kind of bolster that up, and make that work better. And this is just my test pole, like I said. Just got it stuck in there, and some PVC. It's 1.25 inches, an 1.25 inches. They kind of match, so you kind of got to heat that one up to get it to go in there. But yeah, let me edit the video out, and we'll jump over to the VNA, and I'll show you some things on there. Alright, so we'll be right back.
Hello YouTubers. Alright, today I'm going to step you through a little bit of Nano on the instead of using that small little screen, I'm going to step you through on using the Nano VNA app. I got it from the Nano VNA website. Type it in on Google. You should be able to pull it in. Mine looks a little different. I changed the colors and the background settings there. Right here under settings. I went ahead and chose a GUI style cobalt setting, and I changed the the line here for the standing wave above 2. I changed it to a red color. It tells you right there, virtual standing wave line, and that way I didn't like the color layout of the original design, so that's why I did that. So let's step through first. I've got my VNA connected to my computer, and I have it turned on. I fired up the Nano VNA software, and we're going to go over here where my mouse is. I made it big so you can see where my mouse is. And we're going to click this disconnect and go ahead and connect to our VNA. Now, you have to recall, I haven't figured out yet how to select
your recalls from the software. But what I do is I already have my Nano VNA set up for different frequency ranges, and I use the recall feature in the Nano VNA to select the different frequency ranges, the start right here, and the stop. And then anytime you change the start and the stop, you need to recalibrate your Nano VNA. And if you don't know how to do that, or if you haven't got advanced enough to get your Nano VNA working, do some other YouTube searches. I really don't. I'm really not qualified to teach you how to uh, program yours. There's a lot better videos out there, and then you can come back to my video. Um, uh, just open up another tab, and don't forget to subscribe. Um, there's a lot of helpful stuff in here about SDRs and antennas stuff that will help you out if you're trying to get on. If you're trying to get your tech license, okay, let me explain something before I go further. If you get your tech license, you have privileges, full privileges from 6 meter up. You're not going to be able to talk on 80 meter, 40 meter, 20 meter, all that down in the high frequency range. You're pretty well limited to VHF. That's hitting repeaters on 2 meter, repeaters on 440. Um, you can do some 6 meter work, and that's what this antenna build is for 6 meter. If you haven't done 6 meter, it's usually not a very busy band. It's only busy during the skip, what they call skip or propagation. Whenever whenever you're learn a little bit more about radio, and you'll learn what the propagation is in skip. It allows you to talk further. But 6 meter, I will tell you this um, is mainly set up for sideband, and that's where most of the action is on sideband and CW. Now, I'm not going to talk about CW. I don't like CW. I don't really get into the CW thing. I'll probably never become an extra because you got to learn CW. But I'm not for sure if you still have to learn it in general. I think they changed that. I don't know. Um, but I'm going to apply for my ham license, and I'm going to do some YouTube videos on how I do it and how I did it. And but what I was told is to, if you're going to start ham radioing, you want to get into the hobby. You can go about it two ways. You can rush in to get your license, buy you a little handheld walkie, and jump on and get going. But I live at home. Most of my time is at home. And I wanted something that a base station sort of that I can listen to everything. And and if you're going to be just a tech, 6 meters and 2 meters usually where you're going to talk. Um, you can do some FT8 stuff, all kinds of stuff. For the newer generation, they like to do the FT8, have the radios do all the work. They don't like to get on there and talk, apparently, from what I've been seeing on YouTube. But what we're going to do here is get a 6 meter sideband antenna working. And it's going to be a sideband is horizontal. If you go 6 meter vertical antenna, you can do FM work. Now, there's not a lot of work on FM, especially around me where I live. Now, where you live, it might be different, but most of your talk is going to be done on FM or on sideband, and that's horizontal. So you need a horizontal antenna. Um, if you got a vertical antenna and you try to talk sideband, you're probably not going to do very well because everybody's going to be polarized horizontally and you're going to be transmitting vertically. It will work, but not very well. You're not going to get near as far if you don't use a horizontal antenna. So this is my horizontal antenna for 6 meter I just built, and I'll show you here in Nano VNA.
went up here and we connected. Got our VNA connected to the computer. Now I'm going to select on my VNA a range. I'm going to change it from, right now it's set to the default, which I changed. It's 500 to 900 megahertz. And I'm going to recall on my screen, my little screen, and which you can't see. And then, but I'm going to show you. I brought it up, I recalled it. Now, what you want to do is bring your mouse over here to this, set the scan range to match the VNA scan range. Okay, so you're going to click that. Now, what we just did was change the start and stop zone. So for 6 meter, it's 50 to 54. I widened the range a little bit to from 40 to 54 because I was tuning the antenna and it was in the 40 megahertz range. So I'm going to leave it here. Now on your calibration, you can select your desired. If you leave it at none, the VNA's on. But I always make sure that this is selected to VNA, not the app. The app is this, and then you got to go in here and set all your calibration stuff here on this little button. So I always set mine to VNA, that because I calibrated the VNA to 50 ohms, like what you should. Now this antenna I'm testing is inside. If you, I have had it outside and it does better. And what I'll do is I'll edit it into this video and I'll set it up outside and hook it up, and we'll do the same screenshot here. But now that we got it connected, we're calibrations from our VNA. We're going to select the scan range from our VNA, and it changes the values from start to stop. And then we're going to hit our, you can hit the play button here and it'll give you one shot. Or you can do this continuous scan, this one, and you can see changes that affect your antenna. I'm going to reach over and touch the antenna, and you can see how it changes. Brought the standing wave way up. Now on my screen, I changed this bottom one to virtual standing wave. I can't remember what it was set to by default, but I changed it to virtual standing wave. Top one is set to log mag, and this is your Smith chart. You can see the red on the Smith chart. That's where you want to be, your antenna. Now I'll show you with it outside the example I got, but it was all in this red. That's really good. But as you can see, our standing wave here on this screen is 2. 2 is the red line. We are well below 2 across 50 megahertz here, all the way over to 54. Right at 54 we hit 2. Now I will tell you this, it gets better. That is a wide range. This is that is why I used the thicker 6 gauge copper wire instead of the 14 gauge wire. It gives you a wider range here. Your peak is, your range is wider, and you still get a good peak. I don't have the peak now because it's in my room and there's a lot of metal in here. I'll show you the other result with it outside. But I'm not going to go into a complete tutorial for a Nano VNA. But what you want to look for, a few things over here on your chart side. I can't really point to it with the mouse because it goes away whenever I move the mouse over here. So what we're going to be looking at is this one, your reflective, and then your resistive, or excuse me, your resistive and your reactant. Now what that is that this, from what I can tell, I'm no electronics expert, but this, you want this to be about 50 on your R because that matches your 50 ohm coax. The closer you are to 50 on that number, the better off you are. If you're not close to 50 on that number, that's when you need to start thinking about a balun or something else to balance the get it down to 50. This reactance, I think this is X for reactance. You want that to 0. Actually, you don't even want to see it at all. That tells you your antenna is the best. If you're at 50 here and this X is at 0 or nothing, that's really good. You got a really good antenna. You should have a wideband antenna or a really peak, really high Q antenna. The other one we're looking out for is standing wave, and where is it at? Right here is our standing wave. You'll want to keep that one in mind too. That one's going to tell you if your antenna is resonating, and you'll be able to get out and receive. As you can see, when I put the mouse back over, where the marker hangs out is where it's reading from. This showing 1.4, that is perfectly acceptable. You get up to 2 and you got to start worrying, especially if you run power. But I'll show you here after I get it set up outside for you, and you can look at what that is. You can see the reactance is at 66, the R, this number here. I can get it down to, I got it down yesterday to 50-51, which is really good. And I didn't look, I can't remember the X number, but we'll both figure that out on whenever I set it up outside. But your Smith chart, this is your range you want to be at. 50 is right here in the middle. And if you've got just a little dot at 50, man, you're really doing good. That's really good. Anything out here is bad. You don't want that. So you want to kind of keep everything in that range. And you can see when I'm sweeping the mouse, it changes the levels over there, and it changes the traces on the other two screens too. You can see it moving, and so it tells you where it's at. It's kind of nice. It kind of beats the old MFJ meters that just showed you the R and the X and you had to do a lot of menu changes and stuff. This is just perfect. It just shows you everything. So remember a few things about that. If you don't have the software, you can go get it. I got my package. It didn't even say you could go get software. I just saw it on YouTube. Luckily, I went to the web page and it was there. So I'll stop here, and I'll try to get it set up outside, and come back in, and we'll show you what it looks like outside. Now that you got a comparison of what it does, you know it's resonating good down here. So that's what you want, below 2, so you can transmit on it. And like I said, this is a transmit antenna. I'm not going to put it in the SDR receive playlist. So this would be just a high powered, you can run 1200 watts out of that easy. If you put I'm going to put a 1-to-1 balun, a 2K balun on it, so it won't have any problems. And we'll see how that matches. I'll YouTube that video too for you when I get the balun. And alright, well, let's stop here, and I'll set it up outside, and then we'll fire it back up.
Okay, I stepped outside, got it hooked up on a temporary pole there, and head in the room. I got the antenna all put together, got the ends on it. Alright, see, like I was telling you, I live in an apartment, and luckily I got permission. There's the 2-meter compact antenna already up. Coax is in. It's LR 400 from LR 400 Max from DX Engineering, because that's the VHF, very high frequency. You better use good coax. I'm getting 0.08 of loss running the jumpers, so that's pretty good. But there's the antenna, and I'll show you inside. Here's the box, my ground box on the ground rod. There's another two connectors underneath the bottom running the gray coax, and the other's coming down from the roof. That's the ground rod, and all that is a pass-through box to put the lightning resistors in for the ground. Helps ground your antenna. Alright, let's go inside, take a look.
Okay, let's get Nano up. Got the antenna up out. Check it out now. Alright, let's connect and let's blow this up. Big screen for you. Go ahead and connect her. And I'm going to show you guys something. I built this for 6 meter, but if you do a really wide range, we're going to go from basically the start of 5 kilohertz all the way up to 900. And I was shocked to see where this antenna resonates at. I'll show you here. Fire that up. Look at where it resonates at the best. 700 range. It must be a full wave length or something for it to be hitting that low. Because if you look over here, this is 6 meters. It's not even the best out of it, but of course there's about 300, 297, and it has some really low end right through here. I was shocked how low that is through there. But yeah, I wanted to show you all this the wide view of it, because like I said, it seems to resonate really good down here on 700. I was kind of weird. You could probably talk off that, I'm not sure. I'm pretty sure you could if you could actually have rights down there. But let's stop there. You can click stop, and let me change the recall memory, and we'll put it on back onto 40 to grab our settings from the Nano VNA. Now we're going to scan 40 to 54, and we'll do a live scan. But look at that. That is awesome. Now, if you remember the pigtail we had before, it wasn't even hitting 50. It was getting close, but look at it hanging out here at 50 now. Right at 49.66, which your calling frequency for 6 meter is 50.125. So if we step over to 50.1 over here on the frequency, if I can get it to stay, there we go. That's showing a standing wave of 1.0. Wow. So yeah, that's going to be killer. And look at this range below 2 on the standing wave right here. This is a really making that extra length of 6 gauge wire widen the band. You widen the wire, you widen the bandwidth, and this thing is right there at just below 2. That's 47 megahertz all the way over to almost 54. That is killer. So you can see the difference. This is a good antenna right in this range because you're right at the R value here. Let's try to hold it on there. Yeah, it's right at about 50 megahertz, right at about 50, 51. The lower you go, the better it gets, I guess, but right at, trying to lock it in at 50, but there it goes. Yeah, our R value is 52 right there. Man, that is really good. So, let's see what our X value is at our lowest there. Let's stop and I'll do a snapshot. There we go. What is it here? All right. So our X value is at 4, which is really pretty good. I think anything above 15 on your X value there, your S11 Series X value, I'll point the mouse to it right here. I think if it's above 15, that's kind of where you want to be wary of your coax or something wrong with your coax, something in that area. I'm not for sure. Don't ask me. I'm not an electronics expert, but I know you don't want you want the X to go away if you can, be 0, and the R as close to 50 as you can get. And if that, so far this antenna is going to perform well, should anyway. I haven't transmitted yet, but being able to run 1500 watts through that shouldn't be no problem with that low of SWR. So, but that gives you some idea. I didn't take a screenshot of the last one, what it was inside, but this outside one's going to give me the best when I put it on the roof. This is going to be the close, probably pretty close to the way it's going to be. It might move over in this range more towards 50. I think right now it's at 49.66, or it might go up. And you don't know until you get it totally up in the air and then get it all hooked up. But yeah, that's going to be a good antenna. And I weighed it. It's 4.8 pounds with the bracket. So that's not going to be very heavy for that pole. I'm going to put it below the pole on. Let me pull up something here. Yeah, so I'm going to pull that, show that value right there, right at 50 megahertz. We're at 51 on the R value, and standing wave 1.0. That's killer. So there you go. If you need to, if you haven't used the software yet for your Nano, maybe you know where it's at. I went to Nano VNA. That was the brand of my Nano. It's called Nano VNA, and Googled it. Went to the web page. It was kind of bland. Just had like a little box on the left where you can click to get files, and I downloaded this software right here and got. This is way better. If you're building antennas, if you're trying to build an antenna that's resonant, you can get it in this stayed in this low standing wave area, and you should be really good for if you're just learning to build antennas. I was able to change this meter. This one here, it's the S11 Live. The virtual standing wave was not on there, but your log mag is pretty close up here. Right here, it gives you pretty close to it'll won't be as good as your actual standing wave reading right here, but that, like I said, that's helped me out a bunch. And remember your values up there, up here for your R and your X. And if you kind of keep those in range and keep it, know what you're doing as far as that goes, you'll build better antennas. I've seen guys on YouTube just using a standard standing wave meter that they got hooked up in their shack, and they get it close and get it down to 1 to 1 or something, and they leave it at that. But you don't really know what that antenna is doing all the way through the whole band. Unless you go to every channel and standing wave it and whatever. These LNAs are these VNAs are awesome, because like I said, it shows you right here. I can talk the whole band and never have to worry about a standing wave, pretty much. So I built. If you're going for your tech, you're gonna have. And for me, I had to go small, because the lady that told me the building manager here, she told me it can't be a big antenna. And I told her that'd be fine. So I got the tri-bander because the tri-bander will allow me to talk on 2 meter, 40 meter, or 2 meter, 440, and 220. I don't think I'll be transmitting there. Nobody really talks there, but uh, that'll at least give you 3 bands. And the added bonus is that compact antenna is a wide band receive antenna. If you're just putting up a beam or a vertical, that that antenna is going to be tuned for either 2 meter, 144 range, 146 in that area right in there, and that's all you're going to get. So if you go with a smaller antenna like I did, uh, that has the tri band, I can talk all 3 bands there, and it has a very light footprint. It basically is the same size as the mast pole. um, and so, you know, I'm going to put this one up right below it so it matches the horizontal run of the roof, and I should be all set for talking tech. Um, because I was told if you want to get a good and not get disappointed in the hobby, first get your antennas up. Get a receive antenna and get receiving and listen to what they're talking about. Then you start learning how they talk. You learn your QSO codes, and you start learning those, and then you really start learning the bands, and especially if you use an SDR, you really learn the bands. Uh, you know, before I had no idea. Well, I knew, 2 meter was here, but I didn't start realizing, about HF bands, the lower frequency bands, and then, you got to know all that. So, um, setting up your antennas first, getting a receive going, making sure that you learn so much from building an antenna that you probably didn't realize how much you didn't know. I was shocked whenever I first started and how much I really did not know, and I still don't know it all, and I'm probably never going to know it all. But it's important that you don't get discouraged first. If a lot of guys get their license right away and they get a little handheld and they get to talking and they realize, well, hell, there's nobody talking here during the day, or this is just boring. There's nothing to do. There's nothing but digital signals to listen to, and they get discouraged. And a lot of it is because they didn't learn about sideband. They didn't learn about something they needed to know in order to get to that point where you can talk or you can use FT8, and you've got the ability because you've got an antenna that's up high and you're not discouraged by your antenna. Antennas will kill, um, absolutely kill a radio. You could have the best radio in the world and put a crappy antenna on it, and it's a crappy. You're not going to hear crap. So, to me, I had to learn by watching. So I watched a lot of YouTube videos, and that's kind of how I learned to what I was doing. Plus, I had a little bit of knowledge from CB, and I had a 3,000 watt mobile CB back in uh, before I got hurt. But my home station, I had a 7,000 watt system. I had two Drake 2,000 watt linears, and then I was pushing into another one there. And, but that was fun. That was fun talking. And I'll be honest, I've been listening on 40 and 20, pretty much all the bands with the loop antenna, and the ham radio guys bang on CB guys because, oh well, they don't have no control. Ham radio is no different than CB. There you got guys dead keying over everybody. That you got people that are getting fights on the radio. It's hilarious. I didn't think it was like that on 80's really bad, and some of it happens on 40 too. But I'm sure it happens on all the bands. But it's kind of hilarious because it's kind of nothing different. But you got the only difference is you got to get licensed to talk. So, well, anyway, I hope this helps because I think if you build antennas and you get your SDR working, SDR is great to get into it because then you can listen to all of it. And then you learn about antennas. So it's helped me out a bunch. But anyway, I hope this helps, guys. And I'll be bringing you some more videos because I'm going to go get my license soon, hopefully, or get licensed. And then that'll be fun. So anyway, oh, and I do listen to my comments. And Dan, I do listen, so I should have named my last video Alien SDR. You were spot on, dude. I probably would have got a lot more hits. But I do listen to my comments, so thank you, Dan, for that one. Really helped. But anyway, y'all have a good one, and I will see you on the next video. 73s.